Hello everyone, welcome to our daily physics problem, day number 21. So today we are going to talk about there's a rope. A mass m1 is tied onto a rope and mass m2 is tied at the end of the rope. We know the first segment of the rope is length A and the second segment of the rope is length B. We exert a very quick impulse on m1 to give a horizontal velocity of v. What is the change of TA divided by the change of TB? The ratio of the tension force between the part A and part B before and after the impulse. So I want you to pause the video, try your own. If you try it, come back to the video and we'll show you how to do it. So welcome back guys. So first let's lay out what we know because we need to know the change of the tension force. We know the initial tension force and the final tension force. So let's first figure out the initial tension force of TA and TB. We see clearly that TA initial will be equal to m1g plus m2g, and the TB initial will be equal to m2g. What is TA final? TA final will be m1g, which is the mass of the first. And then because we know there's a velocity going right, so we know the segment A. So we know there's centripetal force. It's pointing upward as being protected by the TA force. So we can think about as a centrifugal force downward. So we know that TA final have to balance with the gravitational force, the centrifugal force, and the final tension of TB. So what is TB final? TB final will still be mgh plus something, we don't know. According to the Newton's law, Newton's second law only works in inertial rotation frame. And we know that m1 is accelerating upwards because of centripetal force. So we know m2 have to have the inertial force, this accelerating downward inertial force, imaginary force, we said before. And the acceleration component is v squared over 8. So we need to plus m2 times v squared over 8 downward. Then because we take the reference frame from the m1 point of view, we assume m1 is stationary, then m2 will have a force that's feeding upward. Because even when we know that m2 has zero velocity according to the ground, we still have a force. And it's hard to figure out the force, so we assume that m1 is stationary, then we know m2 have leftward velocity, then you have a centrifugal force upward, centripetal force upward. Now we know the relationship, we can plug it back into TA, so we can have this expression. Then we can solve for the ratio between the changing TA divided by changing TB. Changing TA will be the TA final minus TA initial. The changing TB will be TB final minus TB initial. We cancel out some terms, then we can figure out changing TB and changing TA. We know changing TA will be m1 times v2 divided by a plus m2 times v squared divided by a plus m2 times v squared divided by b. Then the change in TB will be equal to m2 v squared divided by a plus m2 v squared divided by b. All the v squared cancelled out. Then we multiply both sides by ab. So we have m1b plus m2b plus m2a divided by m2b plus m2a. Then we simplify it. We common denominating the m2. We got m2 times b plus a plus m1b divided by m2 times b plus a. Then we divide by both sides by m2 times b plus a. We got m1b divided by b2 times b plus a plus 1. So our final solution, the change of TA divided by the change of TB will be equal to m1b divided by m2 times b plus a plus 1. And that's our final solution.